Can I ask a doubt of week 6 graded assignment?
Week 6 grade assignment.
Yes, sir.
Yeah, okay. Yeah.
I have a doubt in one question.
Okay. Which question number?
The question number 4.
Okay. Okay, let me share my screen. Yeah, this is the question, right?
Yes, sir.
Hmm.
Sir, the second last option. D, I guess.
D. Okay. E. F of x is one-to-one function when x is between minus infinity to 2, right?
Yes, sir.
Yeah. So logarithmic function is already one-to-one function, right? Log of x to the any base, right?
Yes, sir, it's 1 to 1. No,
Yeah.
means that in a specific domain, it's 1 to 1.
Yeah, specific domain is one-to-one. Now, if you see what is the domain of this particular function, f of x, that is minus x square plus 4x plus 12
Minus 2 to 6.
minus
2 to
2 to
6.
6. Okay, so what, because this, the value we should be put, it should always be greater than the 0, right?
Yes,
F
sir.
of x should be greater than 0, yeah. So minus 2 to 6, right? Let me check. What is the, okay, let me take this question. What are the roots of this particular expression?
I guess minus 2 and 6 only.
6, 2.
Minus 2 and 6.
Is x square minus 4. Yeah. So minus 4x minus 12. So that is basically minus 6 into plus 2. So that is 6 and minus 2, right? So
Yes.
our, yeah. So our function should be between in that 6 to minus 2, right? So,
Yes.
okay, wait. Yeah. So that is 6 to minus 2. So if we put any value between other than this, like it will give a negative value, right? So
Yes,
yeah,
that would
what
be
is your
not in the
doubt here?
domain. Sir,
So,
sir, it is
so,
given that in the
uh,
new domain minus infinity to 2,
hmm,
we have to analyze this function.
hmm.
So, but the domain is only minus 2 to 6. So, the values less than minus 2, which are not in the domain, how can we comment anything about that?
No, no. See, we have to see the value for which this term is getting negative. That should not be in the domain of this particular function, right?
Right,
So
sir.
if you put any value between this thing, let's put say, okay, 2. So 4, 8, right? So it is there. It is, if you put okay, we find out that minus 2 and 6, right? Now let us put minus 3 here. What will get? 3 minus 3, 12. So 12, 12 get
Minus
cancelled.
9.
Yeah, no, not minus 9, 9 only, right? Minus 3
So,
if we put here.
minus 9.
Uh, no, minus 3 if we put, we'll get minus 9, minus 3 square, that is 9. Okay, minus 9, right? Yeah. So minus 9, right?
Right. So, that is not in the domain.
Sum to fun function, yeah, that is not in the domain. Hmm. Okay, so if we put minus 4, that is 16 into 16, right? So minus 16, 32. Okay, yeah. Okay, let me think or let me discuss with the team. Okay, I'll get back to you on this. Yeah.
Okay, so the solution PDF says that it passes the horizontal line test in that domain. So, it is 1 1.
Function is one to one, but it is not in that domain, right?
Yeah.
Function will be one to one only. Yeah.
And in that domain, it cannot be even called a function because those values of x do not map to any values of y. So it is neither a function nor we can comment anything about that.
Hmm. Okay, so it is one-to-one function, but we have to see the domain. Okay, so are you asking about that domain, like when x equals to this? Okay, here is the question. Let me see. One-to-one when x is in minus 2 to minus infinity to 4. Oh, here it is minus 2 to 2. Okay, I will get back to you on this. Yeah, I will discuss with
Okay,
the
sir.
team. Yeah.
Thank you, sir.
Hello. Yes,
Sir, where can we find the solution PDF?
it is there in the portal. You can go to supplementary content. You can find out a graded assignment solution. Yeah,
Thank you, sir.
it is supplementary content. Yes. Okay. So now let us start with the week 6 first. Okay, is my screen visible?
Yes, sir, it is.
Yeah. So we'll quickly summarize like what is domain, what is range, what is function, right? It's just one. So what is domain? The set from which the function can take its input. It is basically a domain. What is range? The set of outputs of the function. What is function? For a function of single point in domain, cannot give two different output, right? So that is when x equals to x1 equals 6, it won't be equal to x1, right? So what is linear function? Okay. So what is linear function? When you find out the
Degree should be one.
yeah, degree should be 1. So degree of this variable should be 1. What is quadratic function? The degree of this variable should be 2, right? That is a maximum degree, right?
Yes, sir.
Yeah, it is 2. The what is polynomial function? The degree of any n, a function of any degree. So that is known as a polynomial function. So we can say quadratic and linear are also the polynomial function, right?
Yeah.
Yeah. So now what is exponential function? The function of this type a to the power x, where a belongs to the r. So that is basically a exponential function, right? So what is logarithmic function? F of x equals to log of x to the base a, where x is greater than 0 and a belongs to the real number, where a is greater than 0 and not equal to 1. That is basically logarithmic function, right? So function f is at increasing if we put the value x1 like less than greater than equal to x2, or implies if this condition is satisfied, then we can say the function is increasing. Okay. Or if we are putting the value like this, like x2 should be greater than x1, and we are getting the value like f of x1 greater than f of x2, and for all such cases the function should be decreasing, right? That is basic thing like what we have revised like from the last few weeks. So this is the summary. Now let us try to solve one question based on it. So all the question I have taken in this slide are from the activity and practice question. So also with Solve with Us, there is one separate section on your portal you can see. So I have taken those questions from that only, this question. Okay. So tell me which of the following may represent function that is R to R. So domain is R and codomain is also R. Yes, anyone? But just looking at the figure, we can say that.
Third and fourth.
Sir, 2, 3, and 4.
Second, third, or fourth. Yeah.
Yeah, 2, 3, and 4. Okay, why not the first one?
It fails horizontal line test.
Sir, for the first figure, we are taking any natural input and we are getting real output.
Hmm.
So it's not R to R, it's actually N to R.
Okay. Now in this case,
In this case, sir, it's R to R.
okay,
So
because
we are
the
taking any
function is
values from
Yeah.
Yes, sir, it's a parabolic on the both
Quadratic
sides.
function, right?
So
Yeah.
it's like taking on the minus side as well and on the positive side as well on the x-axis, and we are getting the f of x value. So it's R to R.
Yes, right. So from the thing in option C and D, it is clearly R to R, we can see, right?
Yes,
So
sir.
option B, C, and D is the correct option. Yeah, so simple. Okay. So this one is the second question. Like what we have summarized, we have seen function is said to be increasing. So hint is given to you. Now tell me which of the option is true here. Just look at this figure and go option wise.
C, D, E, and F.
C, D, E, and F. Okay.
C, D, F, not E.
C, D, F. Okay, let us check for the first
This
option.
is
The
yes, a
interval
CDF. Yes, a CDF.
minus infinity to minus 2, minus infinity to minus 2. So that is function is decreasing, right?
Yes, sir.
So this is not correct. Now in the interval minus 2 to 2, minus 2 to 2, clearly we can see function is first increasing and then decreasing. So this
And
is also
then
not correct.
decrease.
Yeah. So in the interval minus 2 to 0, so that is minus 2 to 0, right? So here we can see function is increasing. So this is correct. Now interval 0 to 2, so this is 0 to 2. So the function is, you can see, decreasing, right?
Yes,
That
sir.
is also correct. Now interval 0 to infinity, okay, the function is increasing. This is not correct, because if we move from 0 to 2, the function is decreasing, and after that function is increasing, right? So this is not correct. So in the interval 2 to 3, in the interval 2 to 3, the
It
function
is
is increasing,
increasing,
right?
sir.
Yeah.
Yeah.
So this is also correct. This is simple, that is. Any doubt in this part? In the summary of the previous week what we have discussed, that's it.
No, sir.
Oh, okay. So here we can see, let's say there are two functions f and g, and we can perform some operation like here we can see f plus g of x equals to f of x plus g of x, f minus g of x equals to f of x minus g of x, right? So f of fg into x, that's f of x into g of x. Okay, same thing. Like say for example, I have f(x) equals to x square plus 1, and g of x equals to say x cube. Okay, so I can simply okay, let's take a common, that is 3x square plus so x cube. So I can simply perform the addition subtraction between these two, right? Or multiplication also like this, right? So how to perform the addition? Yes, anyone? What should be the addition of f plus g of x?
X cube plus 4x square plus 1
Yeah. So we need to add the coefficient of the term
of the
having the
same
same
degree.
degree.
Same degree,
Yeah.
yeah.
So here x cube is not there, but we can assume 0 into x2, right? X cube. So that is x cube. Now 3 plus 1, that is 4x square, and that is plus 1, right? So this is simpler. In the same way we can do subtraction also, like f minus g of x, f of x. Multiplication, I hope you everyone knows. And division, yeah, so division also, right? The simple example we are taking. Do you want me to take one example for each case, or it is clear?
No, sir, it is clear.
Clear, sir.
Division operation is clear, right?
Yes, sir.
Yeah.
That the higher degree on the numerator and lower degree
Mhm.
in the denominator, and then dividing the first degree. That is clear, sir.
Yeah, so that is x minus 2. So first we need to make sure that, okay, so degree of like this first term and the coefficient should be same. So how to make that same? It is just simply multiply by x, right? So I will
Yes, sir.
get x into x square minus 2x. So if we subtract, we'll get minus 2x plus 4. So how to make this same, like for x, for this particular coefficient, I need to
Sir,
multiply by,
minus 2x.
yeah,
Sorry,
minus 2.
minus 2.
Yeah. So x into minus 2 we have to do, right? So
Yeah,
that
yeah,
is
yeah.
minus 2 of x, minus 2, that is plus 4 of x. So if we minus it, we will get the 0. So this is the quotient, right? So this simple, I hope you all know the division operation. Okay, so this is the application of what we have discussed now. Yes, just solve it. Which are the correct option here?
Sir, A and D.
Sir, A and D.
A and D.
A and D.
D, yes, sir. For the first one and the last one.
Last one. Okay. Okay. How to approach this type of question? Whether should I calculate f divided by g first, or just put the value then just take the output? Yes, anyone? How to go?
Sir, should
How
I
that do it?
say my approach or just a normal approach?
You can tell anything. If you
Okay.
tell me your approach first.
Okay, sir, since the value we are taking, this is same for both the functions. So what I did, first I calculated f of 2, then g of 2, and then divided that.
Okay. So this thing also we can do. Like at first, if I so f divided by g, then I put the value 2. So it will be it will give me the same result. Yes, anyone?
Wait, it should give same result, no?
Yes, sir.
Okay. So what if I get a
Yes, sir,
quotient
it will
here?
give same result.
So suppose if I'm getting a quotient here, then in that case, what should we do? Because here simply I am getting a remainder here 6. Then in that case, how should I represent this, right?
Say in that case, that would be like x minus 2. I mean, the quotient is x minus 2 in that division thing. And if we get the remainder 6, so it would be like x minus 2. And it is, since it is plus, so plus 6 by x minus 2. That would be the representation of the remainder.
Like we have to find out the value of say q of 2. Say q is quotient, right?
Yeah.
Yeah. Okay. So let us try that. So what I will get f of 2 here. So that is basically a 4 plus 3, that is 11, and g of 2 is basically 2 plus 1, that is basically 3. So I am getting 11 by 3. Now let's do the division operator. Let's try that way also. What we get? Let's see. X square plus 2 of x plus 3 upon x plus 1. Yes, how to do division operation? Okay, let me write in the proper way. So what should be the quotient? Like for what?
So x.
X, right?
Yeah.
So if I multiply by x, I will get x square plus
Plus x.
So minus, it will get cancelled. That is x plus 3, right?
Sir. Yeah.
So then
1,
will
sir.
come in plus or minus?
Plus.
Yeah, plus 1. So x plus 1, that is x, plus 1 plus 1, that is 1. So if I do the subtraction, so I will getting 2
2.
here,
Yes, sir.
right? So f of x divided by g of x equals to, just tell me.
So it is x plus 1 plus 2
Plus
by
2 upon x plus 1.
2 upon x plus 1.
Okay, what is x plus 1?
X plus 1 plus 2 by x plus 1.
2 by x plus 1. So why we're dividing it by x plus 1?
Sir, we cannot go further division to that constant. That's a constant polynomial. So we cannot just go more. I mean, for further more division to a constant
Right.
thing.
Yeah. So now just put x equals to 2 here. What we are getting? 2 plus 1 plus 2 upon 2 plus 1. That is 3 plus 2 by 3, right? So 3 into 3, 9 plus 2, that is 11 by 3, right?
Yes, sir.
The same option we are getting. Yeah. Okay, any doubt in this part? Like everyone understand like how we do x plus 1 here. Okay.
It's clear, sir.
So is B option is correct? F plus G of 1 is equals to 7.
No, sir.
No, sir.
So what is F plus G here? It is x square plus 3x plus 4, right? If I add these two expression, if I put 1 here,
Yes, sir.
what
Yes,
I
sir.
will
Yes, sir.
get?
Yes, sir. Yes, sir.
It is the same.
It will be 8.
It will be 8, right? So
8,
this is not a
yeah.
correct one. Now, okay, tell me in this case, how to approach. Like first I should find out f of 3, or first I should multiply by 2 and then find out f of 3. Yes, anyone?
So we can do any
That
one.
will be correct.
We
Yes,
can do
sir. We can
anything,
do
sir.
anyone.
Like
Hmm.
if we find the f of 3 first, then multiply it with 2, or multiply the expression with 2, then we find f of 3. It will give us same result, sir.
Same result because 2 is constant here, right?
Constant. Yeah.
Yeah. So yeah. So what is f of 3, right? If I put f of 3, I will get 3 square plus 2 into 3 plus 3. That is 9 plus 3,
9 plus 6 plus 3.
18, right? But
Yeah.
into 2 we have to do, right?
Yeah.
So this is not a
That
correct one.
is, yeah, no,
Yeah,
it is not.
that is 36. Now f into g of this 0, right? So either I can do the multiplication of these two functions and then put the 0, or simply I can put 0 here. What I will get? F of 0 is 3, and here g of 0 equals to 1. So that is 3, right?
Yes, sir.
So option D is also correct. Okay, let us try out one just example how to do multiplication of algebraic expression. So what should the multiplication of f of x into g of x? Yes, that is x square plus 2x plus 3 into x plus 1, right? So we have to multiply each term from this f of x to with the whole term in g of x, right? That is x cube plus x square, not 2x, plus 2x square plus 2x. Now take 3 plus 3x plus 3, right? So just add the coefficient of the term having the same degree. That is x cube plus 3x square plus 5x plus 3. So this is basically f of g of x. Now if I put x equals to 0, so f of g of 0, I will get 3 only, right? So
Yes,
this
sir.
is the correct one. Yeah. Anyone any doubt in arithmetic operations like addition, multiplication, division of algebraic expression? Okay, so this one is simpler. Okay, now here we have to find out the value of a. The function is given to x, and this is a composite function f of x. It is equals to this term, right? Then what should be the value of a? Yes, anyone? Just find out.
Sir, it's 2.
2.
Yes, sir. 2, 2,
Okay.
2.
So at first we need to find out the this expression for this composite function, right? F of x. So it will be f of x upon f of x plus a. That is x of x plus a upon x of x plus a plus a, right? I can simplify this,
Yes.
right? Just simply multiplying here. So x upon x plus xa plus a square, right? So I can, if I cross multiply, I can simply uh, eliminate this x plus a from the denominator of both the expression, right? Now what I'm getting, x upon x a plus 1 plus a square equals to x upon 3x plus 4. Well, here you can see the composite function is given to that x upon 3x plus 4. Okay, so now what we can do here is, are you comparing the value or what?
Yes, sir. We are comparing.
Comparing, sir.
So is
Yes,
it
sir, comparing the values.
it will work in all the cases if we compare the expression like this?
Yes, sir. We will compare like a square with 4 and a plus 1 with 3, and we will take intersection of them.
You see, I'm saying a square equals to 4, a equals to plus minus 2, right?
Yes, sir.
So whether I should get a equals to 2 or a equals to minus 2?
A is greater than 0, so A is equal to 2.
Here also it is given, but you can use this whole expression also because a plus 1 equals to 3, right? So a should be equals to 2.
Yes, sir. If that is not given a greater than 0, then we have to do this.
Right. Because when a equals to minus 2, it will not be equal, right?
Yes, sir.
So both the condition you can check. Okay. Anyone any doubt? This is a debate on composite function. Okay. Okay. So first tell me what is tangent? What is tangent? Yes, anyone? What is the definition of tangent?
Can we say that a slope of the curve at that point?
That is tangent.
So tangent is a line that touches the curve only
Sir, a
one
tangent
point.
is a line which touches the curve but do not intersect it.
Touches the curve and which use the instantaneous direction of that particular point, right?
Yes, sir.
It use the direction of the particular point. That is tangent. Okay. So which of the following line is tangent at some point of the curve C? This is curve C. So which of the line is a tangent? Yes, anyone?
L2, sir.
L2
Sir,
only,
L2.
right? Because it is touching at a point here, that is, it will give us the instantaneous direction of this particular point. If you see L1, it is intersecting, right, at 2 points.
Yes,
It is
sir.
not a tangent at all. And this is L3 also, right? So it is not touching the curve. So only a correct option is L2. Okay. So what if this curve is like this V shape, and then I have this particular line? In that case, can I say this line is a tangent to this particular point?
No, sir. I mean, sir, yes, but that's not a unique tangent.
Because at this particular point, we will not get the instantaneous direction, right? It can be in any
Yes, sir.
direction.
Yeah, yeah,
So
yeah.
I can draw infinite number of tangent here, right? At this
Yes,
particular
sir.
point.
Yes, sir.
Yeah. So this is not a tangent.
And moreover,
So
sir, I mean, particularly if we have such like curves which is not smooth, we can just say the straight line slopes are not equal. So that I mean, so actually tangent doesn't exist, isn't it?
where this type of sharp corner exists, right? Sharp
Yeah,
edges.
yeah, yeah, yeah.
Yes, yes, we can say that. Yeah. Because by definition also it will not give us the instantaneous direction of this particular point. So definition itself is failing here, right?
Yes, sir.
So this is not a tangent. Okay. So anyone any doubt in this point?
Does the greatest integer function have tangents?
No, it is stepwise function like this, right?
Yes, sir.
This function. So how we can draw a tangent?
That line itself is a
No.
tangent only.
Yeah. So
Yes, sir.
actually
The
line
line
is
itself
passing to
is
the
a tangent.
particular point.
Yes, sir.
Yeah.
It tells about the direction. Then line itself will be.
The line itself will be tangent. Yeah. So I said this is
Without
the points.
integers.
Yeah. So I can draw like this, then it will become tangent or not?
No.
No, sir.
No, right? So we can say line itself is a tangent in that case, because this integer function is different, right? We are just taking the say floor function, say x. So floor of 3.4 will be 3 only, right?
Yes, sir.
Yeah. So yes, we can say that line itself will be a tangent. Okay. Now this is the same question, different question, just curve is different. Now tell me which of the following straight line is a tangent to the curve C?
L1, sir.
L1, sir.
Curve C. Where is my curve C? This is curve C, right?
Yes, sir.
So if I see L2 is not a tangent, L1 is a tangent at this particular point, L3 is not also a tangent. So we can say only L1 is the correct option, right?
Yes, sir.
Okay. Okay, so any doubt before moving to a sequence for any doubt in tangent or arithmetic operation of algebraic functions? Anyone, any doubt?
No, sir.
Okay. So what is limit of sequence? Yes, anyone? What is limit of sequence?
Sir, for any given sequence, let's say 1 by n, if if the value of n is increasing and the sequence value is like reaching close to a particular point, then we can say, but it is not reaching the actual value of that point. Let's say 0. So we
Right.
can say the limit of that particular sequence is, I mean, tends to zero actually. Sorry, not is zero, tends to zero.
Yes, sir. 0 is not achievable.
Okay, so if I increasing the value of n, so at what particular number this whole sequence will tends to, right? It will not reach that particular point, but it is the limit of this particular sequence, right? So at point this sequence will reach to, right? So what limit I have to take if I need to find out this limit of sequence for 1 by n, for in general also?
So it should be infinity, but infinity is not a number, right?
So as we can increase this number till infinity, right? So we can
Yeah.
consider, say, for any say sequence an, if we find out the value of n tends to infinity as n increasing, as n tends to infinity, so at what particular value this an will tend, right? So that is particularly a limit of sequence. And if you find out this limit, just 1 minute. Say for example, limit n tends to infinity for a of n, and if you are getting a particular value, say L, so then I can say this my limit, this particular sequence is convergent, right? It is
Yes, sir.
converging to the particular L, particular value. It is converging to particular value, that is L here. But if I find out the limit n tends to infinity and I am getting limit does not exist, say limit does not exist for infinity, so in that case I can say this limit n tends to infinity, specifically the sequence of this particular expression will
Divergent.
divergent, right? Yeah,
Yeah.
that is divergent. Yeah. So if you are getting a particular value, so it will converge to that particular value. So we can say it is converges to this particular value L. And if we are getting infinity or limit does not exist, then we can say this simply the sequence is divergent, right?
Yes, sir.
Okay. So in general, if we need to find out the sequence of any say expressions, we can simply take the limit n tends to infinity, right? For a of n. Just find out the value of this particular limit. Now here you can see let an be a sequence of real number where n is belongs to natural number. Here said to limit have a if the number an comes to closer and closer to a as n increases. That's what we have discussed, right? So if a limit an has a an has a limit, then the sequence an is said to be convergent sequence, and otherwise it's said to be a divergent sequence. So there are a few rules. Okay, so if we say that, okay, so this particular uh, sequence is converging to A, and this particular sequence is converging to B. And in that case, we can say an plus bn will converge to a plus b. If there is some constant constant number, say c, then we can say c into a, right? So these are the few rules you can see. Same for division, sorry, subtraction also. An minus bn will tends to a minus b, right? So this is basically the few rules. Okay. Now, and here you can see for multiplication. Okay. So for division, this is the real number and a is in the power. So for any real number, see where a is an is a real number for each n belongs to n, right? So here also you have to point that an should be greater than 0, right, for this particular expression. So then only that case sequence is valid. And this is our I think sandwich principle, right? So if Cn tends to a, if an if Cn is between the an and bn, and an is tending to a, and bn is also tending to a, and if Cn is such that just between an to bn, then we can say Cn is also tends to a, right? So this is basically a sandwich principle. Okay. So any doubt in what is sequence, limit of sequence? Anyone? Just note down these rules. I think in the slide also it is mentioned. Okay, just go through the slide once. Okay. Now tell me what is subsequence.
Sir, one thing,
Yes.
sir. Sir, before you go into anything, sir, can you please give an example for the sandwich principle? It's kind of confusing sometimes. I mean, like
Okay.
while implementing.
Okay. So let us take the same example. Say for, let's say we have an that is -1 to the power n upon n, right? Now I need to find out the limit of this particular sequence. How to do that?
It is
How to find out
diverging, sir.
Minus n bar n
n
into
tends
1
to
by n.
infinity. Yeah. So say if I put n equals to 1, so I will get minus 1 by 1. If I put n equals to 2, in this case it will become plus 1, right? So it is 1 by 2. Then same minus 1 by 3, right? So it will get repeated like this, 1 by 4. So it will converge or diverge.
Diverge.
How? How we can say that it will diverge?
No, sir, it is converging towards 0.
It is converging, sir.
Yes, sir, it is converging.
Here I am getting minus 1, here I am getting 0.5, here I am getting minus 0.66, here I am getting 0.25.
Yes, sir,
So
it is
negative to
converging towards
positive,
0.
positive to negative, again negative to positive, again it will go to negative. So at what point it is converging? If you are saying it is convergent, so at what point it will converge?
0.
It is 0, 0.
0, right? So if I say
0.
that is n equals to 100, in that case it will be 1 by 100, right? So, but how
Yes,
to
sir.
find out this particular limit using sandwich principle? So what is the principle? Yeah. So I can say this my, okay, so let us take say one example. When n equals to 1, it will be minus 1 by 1. When n equals to 2, it will be 1 by 2. And when n equals to 3, it will be minus 1 by 3, right? And let's say this is an, that is minus 1 to the power n, and my bn is basically n. All right. Wait, only n. Now tell me how we can apply the sandwich principle here. Oh wait, we cannot take bn as n. We can take bn as 1 by n, right? Now it will be,
Bn tends to 0.
yeah.
Yes, sir, Bn
So
tends to 0.
It's to 0. Yeah.
bn,
Multiplication, simply by multiplication we can say, sir.
yeah, it will tends to 0, right? So can I apply a sandwich principle here in that case? So when n equals to 1, an will be minus 1, bn will be 1. When n equals to 2, an will be 1, and bn will be 1 by 2, right? So our condition is such that cn should be in between bn and an, right? So what will be an in this case? Negative value means an, right? So that is minus 1, and for bn it is tending to 1, right? So that is tending to 1 for when n equals to 1, right? So if I go by the sandwich principle, will I get okay, but when should not be like that. What should be my an here? This one only, right? If I want to
Yes,
apply
sir.
sandwich principle. Yeah, so my bn is tending to 0, this is for sure. And my this an, which is limit n tends to infinity, it is
Sir,
convergent or
it is
divergent?
diverging.
It is diverging, right?
Yeah.
Yeah. So this is n. Okay. I think in the slides I has taken this example. We can check the slide. Okay. Okay, just 1 minute. So what is given to us here? You can see 1 by n and minus 1 by n. So here I am getting when n equals to 7, I am getting minus 1 by n, and for if I say 1 by n, right? If I do this sequence, say minus 1 by 1, 1 by 2, minus 1 by 3, 1 by 4. So it is between minus 1 by n. Here it is between 1 by n, right? So this is basically my an and this is my bn. So if I apply the n tends to infinity, so it will also tends to 0, right?
Yes,
Minus
sir.
1 by n, and here also it will tends to 0, 1 by n. So I can say when an and bn is tending to 0, so this particular expression cn, right? So that is basically this sequence. I can say this will also tends to 0.
Okay, okay.
We can
Okay.
apply this. Yeah.
Okay. Got it.
Okay. So let us find out the value of this particular sequence. That is, we are given a that is like this, and we have to find out the limit of this sequence. So hint is given to us. We know that 1 by n is tends to 0 as n tends to infinity. It's already mentioned. So in general, if I say when you are taking limit n tends to infinity, now please try to make sure all the terms should be in the term 1 by n only. Then only it is simplified, because 1 by n will directly become 0, right? So try to
Yes, sir.
make all the individual term to 1 by n by dividing with the highest degree. So that will help. Yeah. Let's try out.
So it's 3 by
3
4.
by
Yes,
4.
sir. It's 3 by 4.
Directly we can see it's 3 by 4, right? So if I here you can see at first we need to take n square common, right? Because I want to make each expression in the form of 1 by n, right? Then only I can apply this. So this is general rule, like you must have learned the mathematics. So we're not taking any limit n tends to infinity. So any variable, say x tends to infinity, we always try to make the expression in the form of 1 by x. Okay. So that we can simply put the x equals to infinity, then that is 1 by infinity will be 0, right? So this thing we can apply. So for applying the same concept here, we are taking the n square common from numerator and denominator. Here you can see. And what we'll get this expression 3 plus 5 into 1 by n plus 2 into 1 by n square. And denominator, if we take the n square common, and 4 plus 2 into 1 by n plus 1 by n square. Now if I put n equals to infinity, that is limit n tends to infinity. So this term will become 0, this term will become 0, and this two term also will become 0. So what we are getting 3 by 4, right? So option B is the correct one. Yes, anyone? Any doubt like why we are taking n square common? Why we are converting the expression into like this, like 1 by n? Any doubt in this part?
No, sir.
Okay, great. Okay, now find out the sequence of this particular an. How to do that? Try to make in the expression 1 by n. Can we do f of 1 by n?
Yes, sir. We can rationalize
Okay,
Yes,
how
sir.
to
We
do
can
that?
rationalize.
by multiplying and divide with under root 2n plus 1 plus under root
Plus
2n.
root 2n.
Yeah.
So I can do like this, right? Plus 1 plus upon 2n upon 2n plus 1 plus under root of 2n, right? I can multiply with this, right? So here we can apply a minus b into a plus b formula. So it will be a square plus a, sorry, a square minus b square,
Yes, sir.
right?
2n
So
plus 1
applying the
minus
same
2n.
formula, yeah. So what I will get 2n plus 1 minus 2n, because it will be a square of this particular thing, right? So square root will
Yeah.
go, yeah. So the expression is in the denominator, it is 2n plus 1 plus 2n. So what we are getting 1 upon this 2n plus 1 plus 2n. Now if I find out the limit of this particular expression, what I will get?
We will get 0.
An is convergent.
Yeah, because as n tends to infinity, right?
It will.
This term will increase. Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. So the denominator will increase, right? So it will
Yes,
tends to, so whole expression will tends to 0.
0.
Yeah. So it will converge to 0, right? It is
Yes.
a conversion. We are getting this particular value, right? 0.
Yes,
It will
sir.
converge to 0.
Yes, sir.
So limit of an is 0 and an is convergent also, right? It is converging to 0. Yeah. So that's why I said earlier, just try to make in the 1 by n form. Yeah. So such type of question you
Sir,
can
in
see.
this last step, how that it became 1 by root 2n plus root of 2n, sir? This 2n plus 1 minus 2n, where did it go? Okay, multiply 2n minus 2n. Okay, 1 by. Okay, I
Yeah.
got it, sir. Thank you. Sorry.
So we have formula a minus b, a plus b, right?
Yeah, I got it.
Yeah. Okay. Okay. Anyone, any doubt in this part?
No, sir.
Sir, when an be a convergent?
When an will be convergent, right? So if I find out the limit n tends to infinity of an, and if this particular limit is tending to particular any value, we are getting any particular value, so then I can say that an is convergent, right? So in this case, I'm getting the value 0 if I put n equals to infinity here. So if you are getting any particular value, so that it is convergent. And when the limit of this particular an, when n tends to infinity, this does not exist or infinity, then we can say that an is divergent. Hello?
Okay, sir.
Yeah. So for example, limit n tends to infinity n cube. It is convergent or divergent?
It should in a per specific value n cube.
Sir, it should be divergent.
Yeah. Because if we put infinity, it will get infinity value only, right?
Yeah. If we.
Yeah. So it is divergent. Yeah. It will not converge to any particular value. If I'm getting any particular value after finding out the limit, then we can say
Yeah.
limit is convergent and limit of this particular an is that particular number. So in this case, that is 0, right?
Yeah, sir. Yeah.
Okay. So simpler example again. I think this is from activity question. Let's
3
try
by
to
6.
solve this.
1 by
3
2.
by 6, 1 by 2.
1 by 2. 1 by 2.
So
Yeah.
0.5.
So how should we approach it? Just take the highest degree, that is n square common from numerator and denominator, right? So
Yes,
I'll
sir.
take 3 by 5n plus 2 by n square upon 6 plus 2 by n plus 1 by n square. Now just apply the limit n tends to infinity an. This will tends to 0. This will also will 0, right? So what I will get 3 by 6, that is 1 by 2. It is 0.5, right? Okay, so what is the expression here? Let me see the expression
Yeah.
first. It is from the activity question, I guess. Okay, let me see the. Activity 4.7.4. Okay, the sequence is like this. I'm writing it down here. So we have a sequence 1, 2, 3, 4, 1, 2, 3, 4. Okay, till n. And that is for an tends to n. That is an 10 equals to n, right? And the first option is, which one is the first option? 2, 2, 2. It is 2, comma 2, comma 2, comma 2. Then this basically it is activity question 7.4, question number 3. Okay, so bn equals to 2 for all n. So bn equals to 2 for all n. Now tell me which of the following is the subsequence of this particular sequence. So I have sequence 1, 2, 3, 4, 5, 6 till n, and this is my option A. So which of the options is the subsequence for this given sequence? Yes, anyone?
B and D, sir.
Yes, sir. B and
C
D.
and D. Why? 2 is also here in this, right?
Which option, sir? The first option you're talking about?
First one. Yes.
Sir, if we take that, we don't have the n value, so we cannot
Right.
just change it. I mean, 1, 2, or any sequence value, we cannot just input to any
Bn
function.
Bn is basically a constant, so always it will
Constant,
be
yeah.
for all length it
Yeah.
will be 2, 2, 2, 2, 2, 2, 2.
Two, yeah.
So basically it is not a subsequence, right?
Yes, sir.
Of this particular. Now if I say okay, this is the correct one, but if I'm write like this 8, 6, 4, then 2, then 10, then it will become subsequence if I write
No,
this like this.
no, no,
Why?
no. It has to be a n plus 1 should be more than a n, sir. Generally, it can be a sequence, sir.
Yeah. So what is basically subsequence? We are taking the sequence in the like from the sequence itself. So in which we have to follow the same order, right? I cannot mention like it 8, 6, 4, 2. It should be either 2, 4, 6. Okay. I cannot go in the reverse way, right?
Yes, sir.
I cannot, yeah. So I cannot take this like this 2, 2, 2. Like I cannot do like this also 2, 1, 2, 2, 3, 3 like this. This is also not a subsequence. Subsequence is just we are taking applying this particular condition, that is bn equals to 2n for all n, we will get this sequence, and basically this is a subsequence of this sequence, right? Same in this case, that this is not correct, right? Because here we are getting 10 and then we are saying okay 4 comma 6 comma 8, this is not correct, because here before 4 we are getting 2 and 3, right?
Yes,
So
sir.
either
The
2 should
order
be here,
is
yeah.
disturbed.
Order is not, yeah. So this is also not correct. Here I can say it goes to 2n plus 1. So this one is correct. So option B and D is the correct one.
Sir, I have one doubt, sir.
Yes.
Sir, from that first sequence like 1, 2, 3, 4, and etc. In the given option, sir, first option is like a lot of twos. So I think if 2 is present in one time, then the subsequence it must be a 2 in one time, or it may be present in multiple times. It's possible, sir, or
No, not multiple time. It is not possible because in our original sequence, 2 is present only one times, right? So we
yes,
cannot
sir.
repeat that. Yeah, it's not correct.
So for this, from that point, we can neglect the option B and option C, because only 110 in that sequence and only 1 2 in that sequence. So there is no lot
Yeah,
of 2
this
and
is
there
not
is no
correct.
2 tens. So
Yeah,
that's
this
one
is
is
not
right.
correct.
Okay, sir.
Yeah. Okay. So one more thing. Like if I say option A is like only 2, and when Bn equals to 2, so is it a
Wrong.
subsequence?
No, it is not, sir.
It
Because
should be
then
B1 if
A,
it's given by 2n.
no, if A tends to infinity, then Bn also should tend to infinity, sir. So that only 2 will not be a subsequence.
Only 2 will not be a subsequence.
Yes, sir. If we denote that as B1, then it makes sense. If the if the condition we are taking Bn equals to 2n and we are saying B1 equals to 2, then that makes sense. If we are just arbitrarily
Yeah.
saying Bn equals to 2, that doesn't make any sense because that's constant.
Right. Yeah.
No, but Bn, any sequence means there should be a sequence, no, sir. There
Sequence
should be n.
particular. Yeah. Right.
Yeah, n should be there, n plus 1 should be there. Only one
Yeah.
n, only one element is wrong. And it should tend to some value, either infinity, 0, -1, whatever it is. That is L. So only one element is there, that is not a sequence at all.
This 2 is not a sequence, right?
That's what I am thinking, sir.
Yeah. Yeah. No, it is correct. Yeah.
Yeah.
If I say we have, say, like this example, say we have sequence as that is 1 comma minus 1 comma 1 comma minus 1 comma 1, and then if I say subsequence SB is 1 comma 1 comma 1, okay, when Bn equals to say 1 for all the value of n, then in that case it will be sequence, right?
Yes, sir.
Yes, sir.
Yeah. Then in that case it will be subsequence because it is repeating, right? 1 minus 1 1 minus 1. and we can say SP that is 1, 1, it is subsequence like this. Okay, great. Okay, this is the next question. Just try it out. Let A and B a sequence defined by this one has a limit 1. Which of the following options are true? We have to apply the rules that we have discussed earlier.
So the first one is true. And third one is also true.
How first one is true?
Fourth
We have
one
to
is
find
also
out the limit.
Second one also true.
Wait, no, sir. No, sir. First one is not true. Infinity to the power. Yes, sir. First one is true, sir. Infinity to the power 0. So it gives us 1.
1
so
and 3, correct.
ln1 equals to 0. Log 1 is 0, right?
So can I transfer this limit inside the log? Then only I can say, no, this limit as 1.
Oh, yeah. Yes, sir. Yes.
We can transfer that limit in the log, right?
Yes, sir. So
Yeah.
okay. I did omit that part actually. Sorry.
Only B is incorrect. All are correct.
Yeah. So this is 0. This one is correct. Now if I just transfer this, what I will get? 1 plus 1 2, right? So this is not correct. Now if I n tends to infinity, this will comes to become 0, right? And it will tends to 1, right? Because
To
the
1, yeah.
particular limit has 1. So ln of 2 upon ln of
ln
1
of
plus
2.
1, that is 1, right?
Yeah.
This is also correct. Now what about this fourth option? Limit n tends to infinity 4 n to the power 3 by n. Tell me.
So it will give, sir, 4 into 1 to the power 0.
Limit to the
Power
power cube.
0.
N to the power 0.
4 minus 1.
4 minus 1, 3.
Sorry, limit to the power 0, I didn't get.
No. Limit, not limit, sir. N to the power 3
N
by infinity, which makes n to the power 0. So it's 4 minus 1, 3.
You tell me what is the limit
Sir,
of this
the
particular
fourth
thing.
one is correct.
Sir, why second one is wrong?
Yes. See, what is the limit of this particular sequence? A n 1 upon n, that is 1. So I can transfer this limit inside this expression like log. So what I will get ln 1 plus limit n tends to infinity n upon 1 plus n. So this particular sequence will tends to 1. That is has a limit 1. So that is
It is tending
ln
to 0.
1 plus 1. So that is equals to ln of 2, right? No, this expression is tending to 1, right? It has a limit 1. It is given to us. Hello?
Yeah,
Are
okay.
you getting what I'm saying? Yeah.
Yes, sir.
Yes, sir.
If you simply put that 1 by n is equal to 0, then the answer will 1. Then 1 plus 1 is equal to 2.
Yeah, we are given this limit which tends to 1, right? Yeah.
Yeah.
Okay, so question remains the same. What is the value of this particular thing? Limit n tends to infinity and read upon n. We have given this condition. So what should be the value of this particular thing?
1.
Limit n tends to infinity.
Yes, sir. 1
It will
power
be
6.
1 or 1 to the power cube. We'll get 1 only, but what I'm saying, if I instead of 1 it is a, then in that case what will the value?
Sir, the whole value will be 1. And
No,
1
sir.
by
The
n is equal
constant
to
value would be
0.
there, sir.
Since 1
C into A, sir. The formula
Sir,
says.
please repeat the question.
Okay, so can I apply this rule there? So saying Cn 3 to the power an it tends to 0 to the power a if an tends to a, right? So we have expression that is n to the power 3n, that is limit n tends to infinity, and we are given that one limit n to the power n by 1, n tends to infinity is equals to 1.
Yes, sir, we can apply this. Because this power that this cube, this is finite number, so we can apply this rule, sir. If instead of 3 it is infinite or something else, then I think we cannot apply this.
Okay, suppose instead of 1 it is a. So shall I write a only or a cube here?
Sir, if A is a finite number,
Uh,
then A cube will be there, sir. But if A tends to infinity, very large number like n square, n cube, then we cannot write.
sorry, can you please repeat when n is?
Sir, I
Very
am
large.
saying if A is a finite number, then we can write. But if A tends to very large number, like if let's say A is n cube, and here n is tending to infinity. So if A is a very large number like infinite or something else, then we cannot do.
But let's say suppose it is an integer value, in a real value, then in that case.
Yes, sir. I think if it is a real value, then we can do so. We can write so. And yes, sir. We should. I think we should take care. No, no. We can write, sir.
We can write, okay. Just how many of you know limit here? So what should be the value of this?
16, sir.
16.
16, sir.
16. So if I express like this, plus 4, then apply limit extends to 2. What should be the value?
4 plus 8 plus 16.
16, right? So can I apply the same principle here?
Yes, sir, we can.
Yeah. So here, what will be our answer? 4 into 1 minus 1, basically that is 3, right? So this is also correct one. Okay, great. So yeah, I think limit of sequence. Any doubt in this part? We are.
Sir, I have not doubt in this part, but the question, I think the question is taken from Solve with Us, which provided
Yes, it is
in
on the
week
portal.
7.
Yeah, yeah.
Yes, sir.
So all the
But
questions are
I
from
think,
that only. Yeah.
yes, sir. From there, there is a written a heading above where linear expression is ax plus b. But I think, sir, there should be mentioned a should not equal to 0. It is not mentioned, sir. In linear equation, a should not be 0, right, sir?
Okay, right.
Yes, sir. Even in the exponential, a should not equal to 1. That is also not written over there.
No, a not equal to 1, I think it is, yes, sir, that is also not written there.
In the key points, you were saying, right?
Yeah.
Yes,
Right.
sir, in first key point, sir.
A should be not equals to 1. Yes, that is correct. We have discussed in the last session only. And what you are talking, what we discussed like earlier, what you said?
Linear equation, sir. Linear equation.
Expression. Okay.
A linear function. The definition of linear function. There a should not be 0.
A should not
That
be
is
0.
not mentioned there. That is not mentioned there.
Yeah, it is mentioned for all the real number, right? Okay. If
Yes,
a is
sir.
equals to 0, then there is a constant term, right? Okay. Okay, no issue. Yeah. Okay, tell me, what is limit?
Limit is surrounding value, sir, where a function approaches.
Sorry, limit is surrounding value. I am not getting.
Sir, in crude language, I was saying it is a surrounding value. In appropriate language, sir, in mathematical, sir, a limiting value is value. It is a finite value, for which is also the left hand limit and also the right hand limit.
It has both left
The
hand, right
limit
hand.
is a point where all the
Left hand
values of
limit
the
and right
function
hand limit
approaches
should
to
be
it.
equal and should be finite.
It should be equal, right? Yeah, both the limits should be equal and it should be finite, right? Then we can say
Yes,
limit
sir.
exists, right? At particular point.
Yes, sir.
Yes, sir.
Yeah, yeah. So both the side means like if I find out this is f of x, okay, we have point A.
Yes, sir. If both
So we
side
want
are in function domain, if it is not function domain, then we will check from only one side.
yeah. So what this indicate like we are just reaching this particular value A and what value this f of x will tends to, right? This particular limit. So I can go this A from two side, from left hand side and from right hand side also, right? So that is left hand side I can consider this as limit x tends to A negative and f of x. And for right hand side I can say limit x tends to A plus then f of x, right? Now here we can say the limit exists because this is a continuous curve. You can see like for this continuous curve limit will always exist. If we go from the left hand side or right hand side, we'll reach this particular value only. Right? Hello?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
So now this is a graph of 1 by x. Now tell me limit x tends to 0. 1 by x. Limit exists or not? This is 0, right?
No, sir. Limit does not
exists.
exist.
We are.
Limit exists.
Which one,
Does
sir?
not exist.
No,
Does
sir,
not
it
exist.
doesn't
No,
exist,
sir.
sir.
No,
Does
no,
not
sir. It is
exist.
not in
Doesn't
domain.
exist, sir.
1 by
Sir,
0
it does
tends.
not exist.
That does not exist, right?
Yes, sir.
Yeah. So when I say x
Asymptote.
tends to 0, sorry. Yeah.
At x is equal to 0, there are two asymptote passing from that.
Right. So when I'm saying when I'm going from left hand side, right, I will go from this side, it is 0 negative. So I'm not just reaching this particular point 0, right? So this function is basically like this. When I'm reaching 0 from right hand side, this expression is like this going, right? So we are not getting any particular value at particular point. So it will not tend to any particular value. So we can say limit does not exist here. Okay, one more thing, say I have graph like this and say this is point. This is the point and say this is point B. So can I say limit at point B exists when x tends to B here?
No, sir. Limit will not exist.
Yeah. So whenever there is a continuous curve, smooth curve, then we can say in that particular domain, we can say for all the value limit will exist, right? But whenever there is a, like this thing, like this break in the particular curve, then we can say at that point limit does not exist. So now let us go to the key points. If x approaches to A from the right side of A, then the value of A approaches to LR, that is denoted by x tends to A plus, right? And if x approaches to from left hand side, then it is denoted by x tends to A minus, that is f of L minus. And if this both limit are equal, okay, and reaching say particular value L, then we can say limit exists and that limit is particular this value L. Okay, so this is how to evaluate that limit. Anyone, any doubt?
Sir, I have doubt while solving this type of question. I encountered a polynomial by polynomial functions. Could you please, sir, later on after completing this, explain how to draw the graph of polynomial by polynomial function? Is there any general method?
Polynomial by polynomial function. You can simplify that first. That thing you can do. And then you can see whether we can draw it like or not.
Sir, means sometime we cannot draw. It is not always possible to draw, sir.
Right, yeah. Okay, we'll see that. Yeah. I need to think about that example. Okay. Okay. Any doubt in the limit part? Anyone? How to find out the limit at particular point?
No, sir.
Okay. Now let us take one example. This is f of x. Okay. And which of the following options is are true? So it is equals to 1 when x is greater than or equals to 0. and equals to -1 when x is less than 0. Yes. So limit x tends to 0, f of x equals to -1. It is correct?
No, sir.
No, sir.
No. X tends to 0 means that is sorry, x tends to 2 means this one, right? So it will be 1.
Yes, sir.
It is not correct. Now x tends to 0, the limit exists. X tends to 0.
No, sir, doesn't exist.
So if I go from the left hand side, f of
Then
x, what should be my
it is
value?
-1.
It is -1.
-1.
If I go from right hand side, it is 0.
It will be 1, sir.
It will be +1, right? So this is not
Yeah.
equal. Though both the limit exists, but it is not equal. So I can say limit does not exist at x equals to 0, right? When x tends to 0. So this is not correct. Now limit x tends to -0.5. It is equals to 1. Is it correct?
Yes, sir, it is true.
Yes, sir, it is
It
true.
is true, sir.
Yeah, this is correct. Now left limit at 0, that is 0, f of x equals to -1. Is that correct? Left limit.
Yes, sir, it is also true.
So left limit
Yeah.
is correct, sir.
Yeah, left limit is correct. Right limit is, it should be +1, right?
Yeah, it should
Yes,
be
sir, it should be
+1.
This is not
+1.
correct. Right limit at 0 does not exist. Is
It
this
is
correct?
existing, sir.
Yeah, it is going to 1,
Yeah,
right?
it is 1,
So
sir.
yeah, so this is not correct. Limit of the function at 0 does not exist.
Yes, sir.
Yes, sir,
It is
true,
true.
true.
So left hand
Correct, sir.
limit is not
Correct.
equal to right hand limit, right? So this condition is not hold here. So we can say limit does not exist. So limit of the function does not exist any real number. This is not correct. So any
Wrong.
doubt in this part? Anyone?
No, sir.
Okay.
The limit at 0 does not exist.
Yes, limit of the function at 0 does not exist, right?
So actually, what will be the limit of the function at? I mean, what will be the value of y at 0, sir?
There is jump at 0.
Yeah. So if you draw the graph like this,
F
it
of
will
x.
be
Yeah.
f of
Yeah,
x.
it is 1.
At 0 equal to 0, they are not given.
They are given function value is 1.
So it
Actually,
will be like this.
sir has draw a
-1,
red pen there. There is
1.
equal sign.
Yeah.
And you
When
can see
x
when
is
it
more
raised to
than 0.
left hand side, yeah. So it will be like this. This
And
function
if
will be like
that
this.
is equal not mentioned, I think that will be not, we will not consider in domain, right, sir?
Yeah, yeah. Right.
Sir, this function is like signum function.
Sigma.
Signum function, sir. Signum.
Yeah, but at 0, it should be 0, not 1.
Yes, sir.
You can see at exposure it will 1, right? This is
Yes.
dark circle and this is empty circle. You can say like this.
Here it is given as okay. Does not exist.
Yeah.
Limit at 0.
Because left hand limit and right hand limit is not equal, right?
Yes,
So
sir.
left hand limit is -1 and right hand limit is +1. So it is not equal. So we can say limit of the function at 0 does not exist.
Okay.
Okay. So okay. Any doubt in this part?
No, sir.
Okay. So this is the simpler one. Just try to find out the limit of this particular for all the option.
So in this question, first option I'm calculating, but getting 0 by 0 all the time.
The
Getting
first
0
option
by
is
0.
true.
So it is indeterminate form, right? If we put -1 here, so you will get +1 +7, that is 0, right? -7. And here 1 plus -3 plus so it is 0. It is 0 by 0 form, right? But can you think about simplification? Like,
Yes,
can
sir,
you
we can
simplify this?
factorize it.
Factorize
Yeah.
x
So what is the
by
factor of numerator?
x minus
X
1
plus
into
1
x
and x
minus 6.
minus 7.
X minus 7, x plus 1.
Okay. And in the denominator?
X plus 2,
X
x
plus
plus 1.
1.
X plus
2.
2.
Now we
So
have to
we can,
substitute.
Yeah,
That's
so we
1.
can cancel it out, right? Now just apply the limit x tends to -1. Just put here -1 -7 -1 + 2. It will be -8, right? So this one is correct. Apply same thing here also. Same option. No,
The
not same
second is
option.
At
wrong,
x
sir.
equal to minus at x equal to -1, what happens, sir?
When x equals to -1, it will tends to -8 value, particular value. This expression.
That's correct. In the function,
Function is not
yeah,
defined
-1.
No, no.
at that
Limit
point.
exists here, but it is not a continuous function. That we'll discuss in the next week. Don't worry.
Okay.
Yeah. Because this function is not defined when x equals to -1 and -2, right?
Yes, sir.
Yeah. So function is not continuous, but limit exists.
Okay. Correct, sir.
Yeah. Okay. Now check for option 2. Sorry, B, C, D.
So C is correct, sir.
Okay.
Yes, so C
Let's
is correct.
discuss about when x tends to 0, just put 0, 0 -7/2. That is not correct, right? So this is wrong. See, now if we put x equals to 2 here, just simply put that is 2 cube plus 4 into 4 minus 6 into 2 minus 7, 8 plus 16 minus 12 minus 7. So it will be 4, 12, 5, right? This is correct. Now what about this?
Sir, wrong.
So that is 0, sir, for the last. Its limit extends to 0, extends to 3, x minus 3 we are getting. So it should be 3 minus 3, 0. Yes, sir,
We can
like
write
this
like
form.
this.
Yeah, like this form, sir. Yeah.
So 3 or x tends to 3, x minus 3 will be 0, right?
Yes, sir.
So this is not correct. So option B, sorry, option A and C is the correct one. Okay, any doubt how to find out the limit?
No, sir.
In this week we're just simply putting the values and just finding out this limit. But in the next week we'll discuss about the continuity part. We'll discuss about the L'Hospital rule also, like if indeterminate form is there like 0/0, then how to approach. Okay, so that thing we'll discuss in the next week. In this week, just limit conceptual is there. Okay. Yeah.
Its syllabus for this calculus is broader than the class 11 12th, or it is narrower than 11 12th
It's narrower than
for
11
this
and 12.
BS.
Yeah,
Okay, okay.
It's just yeah. We're not touching all the cases, right? Just what are the important things are there in calculus that we are discussing. That's it.
I have a query about the course.
Hmm.
Sir, is this like mathematics will be useful in our
Yeah. So
data science?
yeah, there is one
Implemented.
practical implementation means what you will be able to apply all this concept when you are dealing with MLP, MLT, right? Machine learning part. So where you should know how to find out the limit. So applying the concept is more important there. Yeah. So if you talk about ML, like machine learning part, so it is the application of maths and stats. So you should be familiar with maths 1, stat 1, M2 and stats 2. Okay. So these 4 subjects are the basic, you can say, building block of machine learning. And then it is in the diploma level.
So for quiz 2, what will be the syllabus?
Week 1
Week
to 8.
1 to 8.
Uh,
Okay.
yeah. Okay. This is the last question.
Sir, is it equally distributed, or more focus will be on 4 to 8 weeks?
You can say that, but the question will be there from week 1 to 8 always. Yeah.
And sir, level of question will be higher, means in qualify, it will be harder question than qualifier exam.
No, same level, same as PAGA question.
And PAGA, practice and graded assignment.
Yes, right. But only case is that here we are just discussing only one concept in one question, right? So there can be in some question you have to apply multiple concept. So concept from week 3, then week 4, then week 6 also. Like we can make such type of question in quiz. So here it is straightforward because we are just dealing with one weak content, so we can think in that direction only. But in the
And
quiz, you can
15 to 20 question will be there, just like in qualifier.
I don't know about the number of questions, but yeah, at most 15. Yeah.
Okay, sir.
Okay. Yeah. So just go through the content and solve, practice and grade assignment. That will be enough. Yeah. So this is the last question. A similar question as of previous one. You have a function f of x, and this is the option. Which one is true?
Limit exists at x equals to 2.
Limit exists at x equals to 2. Is it correct?
Yes,
What
sir.
is left hand limit? X tends to 2 negative. That is x, right? So it will be
Yes,
2.
sir. X 2 only.
Right hand limit? Limit x
5,
tends
sir.
to 2. Yeah, it is 5, right? So it is not equal, right? So left hand limit is not equal to right hand limit. So I can say limit does not exist. This is not correct. Right limit exists at x equals to 2. Yes, it exists, right? It is
Yes,
5.
sir.
Yeah. Left limit at x equals to 2 is 2. So left limit at x equals to 2 is 2. This one is also correct.
Yes, sir.
Right limit at x equals to 2 is minus 1. No, it is 5, right? So this is not correct. So option B and C are the correct one. Okay. Okay. I think we have solved all the questions from solve with us registered in the portal. Okay. Try to solve practice assignment question and graded also. Yeah. Yes, Naren?
Sir, I have one doubt in graded assignment 6, sir.
Okay.
The
Which question?
Euler problem. The
Which
Euler,
question? Okay. Jeweler.
question
Okay.
8.
Uh,
Choose the correct option, 8.
okay.
Sir, in that, Euler sold at least 540 kg gold in 2019. So yes
Jeweler
or
sold. Okay. Okay. Let me share my.
And sir, whenever the word curve is mentioned, and if we get solution, a straight line, then will we consider that as a curve?
Yes, straight line is also curve, right?
Okay, sir.
Curve means we can draw anything just by don't lifting our pen.
Lifting out the pen. Yeah.
Means if there is break,
Smooth curve.
that is
Yeah.
not curve. Means tan x is not a curve, sir.
In that particular domain, it
Curve
is
in
curve
the
from pi by 2
range.
to minus pi by 2. Yeah. Minus pi by 2 to pi by 2, it is curve, right? That domain.
Yeah,
this
yes,
is
domain.
Yeah. Okay,
yes,
Naren.
Euler sold B. Option 2 is Euler is sold at least 730 kg gold. We are accepting. So anything which is lesser than that also, at least the option number A1 is the jeweler sold at least 540. Yes, he has sold at least 540. No, sir. Why? How can it be wrong?
No. Jewelers were at least 730 kg means minimum 730 kg he is solding. Okay. So more than that he can sold. Right? In 2019. At least means minimum 730 kg. Right? So you're talking like
Okay, at
730 we
least.
can, so why not 540, right?
Yeah, yes, sir.
Yeah, no, not like that. At least 730 means minimum
Minimum.
7,
Okay.
yeah, minimum 730.
Okay. If it that 540 instead of 540 it was there 740, then that also is wrong, right, sir?
At
740
least
instead of
740.
540. At least
No,
740.
that is also long. We have to find out the minimum value, no? At least 740 or at least 730. So if you do the calculation, you should get some value, right? So that is Says 2 kg gold. Yeah. So 730 kg gold. So at least 730. If there is 740, at least that one is wrong.
At least.
Yeah. Okay. Anyone? Any
Sir,
doubt?
one more, sir. Yeah, I want to get explanation regarding that reflexive set in set theory, sir. I mean, our week one. It is there in the our qualifier first question.
Qualifier first question.
Relation, reflexive relation. One of the, I mean, our this thing it was told that reflexive is you should have all the elements. If 1, 2, 3, 4 is there, 1, 1, 2, 2, 2, 3, 3, 4, 4. If it's there in the subset, then only the that is called relation is reflexive. Correct, no, sir? What is reflexive, sir? Can you please explain?
Okay. So are you talking about any question in the qualifier?
Yes, sir. First question.
Let me take that question. There are so
Sir,
many.
is all question over? Could we leave this session now?
If you don't have any doubt, yes, because I have discussed all the questions from Solve with us. Yeah. I'll just take doubt
Okay,
and
sir.
then close the session. Yeah.
Thank you, sir.
Not first question, sir. 1 second.
Sir, I am new here, sir. Can I ask a question in
Sir,
Hindi?
8, sir.
Yes, just 1 minute. Let me take this question, then we can ask. Pankaj, right?
Yes, sir. Yes, sir.
Yeah. Just 1 minute.
Question
Let
number
me
8 and it could be 10.
education. Question number 8. Yeah.
Relations.
In total, how many relations given in the column A matches with reflexive relation, right? That this question.
Yes, sir.
Okay. Let me take that question. Where is the relation given?
Starting, sir. Table 1. Page number 8. Little bit.
This is the question, right?
Yes, 68.
68, na? This
No,
one?
no. My question paper it was 8. How many relations can you call matches? Yes, sir. Correct. This
Okay.
only.
Okay.
This also and before 2 questions, sir. 66 might be true or false. R1 matches with any relations with anti. Not.
Okay. So we have a table here, table 1, right? So based on
Yes.
this only we have few questions.
Yes, sir.
Yeah. So in the how many relations given in column A matches the reflexive relation? Reflexive relation. Yes.
Sir,
R1,
what I
2,
was
3 is there,
thinking
na?
is R11, first one R is 1, 1. Whether that is reflexive or
Right.
not.
That is reflexive, right?
That's what I was. I mean, after I saw the answer, I can find out. But the definition was reflexive relation. All the elements in the set has to be there. 1, 1, 2, 2, 3, 3, like that. All is because in our previous question paper, one question was there. If it is reflexive, what will be the subset cardinality of subset R? If there is
Yeah,
a
so the
reflexive.
subset cardinality is different. Yeah,
No,
subset.
no,
Here
minimum.
just
No,
minimum.
I'm just telling minimum.
Mm.
The answer was what is be the subset relation if it is a reflexive. Minimum we are told for a set which is having 3 cardinality, minimum set in the relation which is having reflexive relation is cardinality minimum is 3. So why it is 3? Because it has to have all the 3, 1, 1, 2, 2, 3, 3, all the elements of the set has to be there. This was the sum of the explanation given when that problem was solved. It has to contain all the what you call elements of A. So in
Yeah,
that
but here we are talking about the match the pair, right? Relation R column A. So relation R is subset of A by A, right? Here you can see
yes, relation is
subset of A by A.
subset
Here
of
we are
A by
talking
A.
about which one is the reflexive relation. So R1 and R2 are reflexive relation here.
No, but the R should contain all the elements, no, sir, to be reflexive, not required. Okay.
No, here we are talking about a subset
So
A2, right?
there should be every element of A in like 1, 1, 2, 2, and 3, 3. This is the definition of reflexive.
Reflexive, isn't it,
But
sir?
here we're talking about the relation R is subset of A, right? So this is subset of A. Now we have to see because you can
So
see
all
1,
are
1 is
subsets of
subset of
A.
R2.
R1 to R6 are all subsets of A, sir. That is understood.
That is, yeah.
But whether R1 is having reflexive relation with the A. With respect to A, set A, whether R1 is having reflexive relationship or not.
It is there, yeah, 1, comma 1. We can say that, right?
No, sir,
Then
for
we have
every, there is every word in the definition.
For all the value.
please take down we'll refresh that definition, sir, once again.
Okay, okay. Okay, let me discuss with the team. Yeah,
Please,
discuss.
sir. In that case, if we say 1, 1, that is one, then how many? Then it is true, sir. What you told is true, because 1, 1, R1 also is there, R2 is also there. Whether R3 is there, sir? R3 is having
R3, no.
reflexive relation.
No, 1, comma 2 is there, right?
Okay, R4.
R4 is also not there. Only R1 and R2 is there, right?
Even R5, R6 also, as per me, he is saying 5.
So here we're talking how many relation column A matches reflexive relations. So R1 and R2 are the reflexive relation, right?
No, sir. R5
I
is
will,
also,
yeah.
as per the definition, R5 is also relation as per the definition, because you are having all the 3, 1, 1, 2, 2, 3, 3. R2 also is there, 1, 1, 2, 2, 3, 3. As per me, it is only 2.
1, 1, 2, 2, 3, 3.
R2 and R5.
So,
R1, 2, 2, comma 3, 1, 1, 2. So
so,
let me see 1, 2, 3, 1, 1, 2, 2, 3, 3. Yes. Yes.
In
sir,
last
it was told to us that relation is said to be reflexive only if all the elements are present.
All the elements are present, right? So if
Yeah,
you
it
consider
should
1,
be
2, 3,
1,
1,
1,
1,
2,
2,
2,
2, 3,
and
3,
3, 3.
three
Yeah.
other
1, 2.
elements can also be present. For identity, other elements cannot be present. In last year section, they have explained.
Okay, I will go to the slide. What is given in the slide? I will check it once. Okay, definition.
Yeah, that is one.
Yeah. Okay. Any other doubt in
R6
this?
does not match. R6 does not match with any type of relation given in column B.
So
When R2 is matching with reflective.
Your voice is getting repeated.
excuse me, sir.
Yes.
Sir, I have a doubt in SSE.
like last
Yeah,
question.
just
Let us
one minute.
finish this first.
Yeah, just one minute. Naren, yeah, 66, right?
Yeah, just
65.
Naren, yeah, 66, right? 65.
Yes, sir. R6 does not match with any type of relation given in column B. Answer is true, which means it should not match. But
Yes, sir. It should not even match with reflexive.
Yeah, so it is reflexive now, right?
It is not reflexive. 2, 2 and 3, 3 are not there.
but transitive is there, no, sir? 1,
Yes,
comma
sir.
1 and 1, comma 2 transitive relationship is there.
For
A comma 1, comma 1 is A, comma B, and 1, comma 2 is A, comma C. So, I mean B, comma C. So 1, comma 2, it is a transitive relationship is there.
1, 3 is not there.
1,
How
3
it is
not
transitive?
no, first element 1, comma 1 is A, comma B. Second one is B, comma C, where B is 1 and C is 2. So again 1, 2 is again A, comma C. So that is it's the transitive relation.
For 2, 3, it is not there. If 1 it is not satisfying also, it is not transitive relation.
Is it so,
So
sir?
for, yeah, so the transitive of this 1, 2, 3 will be like, yeah, so you can see 2, 1. Yeah, it is not satisfied, right?
So for
It
this
contains
is
1, 3.
sir, R3 is transitive or not, sir?
R3 is 1, 1 and 1, 2. These are transitive, right?
So just because we are having in R6 another 2 elements, it is not transitive.
2, 3 is there, but does it is 2, it should contain 1, 3. Then we can see, right? Then we can say it is transitive, right?
So R6 is not having any relations.
No. Yeah. So 2, 3 is not there.
Transitive should have for all the elements there should be a C wherein A and B is there.
Yeah. So if it is 1, 3 is there, then we can say that, right?
1, 3, how can you say, sir? Because we are having 2,
R6.
1 also and 2,
2,
3
1,
also.
1, 1, 2, 2, 1. Okay, so 2, 3 is not there. So 1, 3 will not be transitive.
2, 2 should be.
2, 2 is there, then it is, yeah, there.
But again 3 also is there, 2, 3. For that also transitivity should be there.
No, like if it is in the set, if we mention say 1, 3, then we can say, right? Because transitive.
No, I am not understanding. That's why I'm asking, sir. Transitivity, exact, what is the definition, sir, to be transitive relation?
Okay, let me check.
My understanding was if any 2 elements, if it is having A, comma B and B, comma C and A is equal to C, that is what my understanding. I am not thinking more than the second one. Third element, fourth element, fifth element. You then transitive means for all the elements it should be true. What you are telling them.
For 2, it will be transitive. It should be 1, it should be there, right?
No, I am seriously, sir. I do not know. That is why I'm asking.
Okay. Let me check. In I remember which slide it was there. Discuss. Week 1, I guess, right?
47.
1, 7 transitive relations. So what definition we have given in the slide?
If that's what, sir. A comma B, then B comma C, then A comma C is there. It should be then is a transitivity relationship is there in the set in the relation.
Okay. Reflexive. I guess we have set examples relations.
Yes, sir. Yeah.
Symmetric transitive relation here you can see, right?
Reflexive, see, sir, for all reflexive will also see. The reflexive A comma B, then for all A is more than one.
Here is occurring A is vertical slash A for all A greater than 0, right?
A comma B, element of n comma B, where A and B is more than A.
We're talking about the set, so that thing is clear. But
We
now
got
about
the transitivity.
transitivity, you are
Yes.
yeah. So if you say transitivity here, say we have A comma B, then if A and B, yeah. So if A, B and B, C, then we say A and C, right? So
Yeah.
say A tends into B and B tending to C, when directly we can say A tends to C, right?
Yes,
This
sir.
is transitivity, is right?
Yes, sir. Correct.
Yeah. So in the question, what is given?
No, R6, they are having extra two elements also. See, first two elements only when I take 1 comma
If you
1
take two
and
first
1
two,
comma
yeah,
2.
yeah,
So A by A is 1 and B is 1.
it's 1, right?
Next
Here
element
also,
B
yeah,
is 1 and C is 2.
C is 2. So I can say
So
1
A
comma 2.
tends to, yeah, 1 comma 2 and second element is 1 comma 2, which means transitivity relationship is there.
R6, where is, are you talking about R6 or R3?
R6.
Yeah, 1 comma 2 is not there, na?
The element same,
Okay.
that 1
Yeah,
comma 2 is
same
there.
element we repeated. Okay.
Yeah, it can repeat.
Okay. Yeah. So now just take 1 comma 2 and 2 comma 3. Now 1 tending to 2, 2 tending to 3. So 1 comma 3 is there.
Yeah. So,
No, right?
no, it is not there. So, which means in that relation, all the elements should satisfy
The condition, yeah.
all the
The
elements.
particular condition. All the elements, yeah, of this set. So yeah, as you said, 1 comma 1, 1 comma 2. So we can say 1 comma 2 is there. Now if you take
Yeah.
1, 2 and 2, 1. So 2 tending to 1 comma 1 is already here, right? If you take these two, A, B and this A, B. Now just take 1, 2 and 2, 3. That's what's saying. 1 comma 3 is not there, right?
Yeah,
So
it is
if you say
not there.
1,
So,
yeah,
you know, if my understanding is correct and what you are telling is right, this in the relation, all the elements should satisfy.
yeah. In this particular relation, all the elements should satisfy that particular definition of this relation. Then only we can say.
Okay, so that is the relationship for transitivity.
Yes, yes.
All I should take all. So
Yeah.
that means R3 is having transitivity.
R3, if we say 1 comma 1, 1 comma 2. Yeah, we can say because 1 comma 2 is there, right? Yeah.
Okay.
If in the R6, 1
R4,
comma
sir?
3 is there, R4 only 1 comma 3 is there. So can we say only A and B is there, right? The third term is not there.
So C is
Then
not
also
there.
satisfied, right?
Yeah. Sorry?
A is 1 and B is 3. Yeah, again, B is 1 and C is 3. So A is 1 and 3. Will it satisfy?
Is for R4.
R4, sir. A is 1 in first part. I think A is 1, B
Right.
is 3.
3.
In next, I'm saying B is 1 and C is 3.
3.
So
Then we can
1
say
comma
that. Yeah.
A comma. So R4 is also transitivity is there.
Yes, R4 is also another is there. Yeah. 1 comma 3. Again 3, 2, 1. So we can say 1 tends to 3. Yes.
So R4, R1 also a transitivity is there.
R1 is also transitivity. Right.
So this is a transitivity.
In
Okay,
only
sir.
R6, 3, 1 comma 3 is there. That's what I'm saying. If 1 comma 3 is, then we can say it is a transitive. Because if you say 1, 2 and 2 to 3, so 1 to 3 should be there, right? 1 comma 3
Yes,
should be
sir.
there. It is not there. That's why. Yeah.
No problem. Okay, so this one clear, sir. But regarding this reflexive relation, you have to come back, sir.
Yeah, I will show. Yeah.
Excuse me,
I
sir.
will go through the slide once. Yeah, yes.
In supplementary content in books, it was explained, sir. Reflexive, transitive, with example, almost same question.
Okay. So yes, Naren, maybe you can go to the that book. Yeah, it is there on the slide in the portal.
Which one, sir?
On the portal, where there is book section, you can see on the left hand side. You can go through that book. Examples are given in that book. The portal, if you see supplementary content, books
Yeah,
are there. Right?
I have gone there, sir. 2 books are there. Calculus and these 2 books are there.
Week
I
1 to
will
4,
see
you can
that.
go through that.
So, yeah, I will see that. Still, if you are not convinced, you also please confirm it, sir.
Yeah, I will confirm. I will see the slide. What is going in the slide? Yeah.
Yes, sir. Thank you very much, sir.
Sure. Okay. Okay. Yes, Pankaj. Oh, yes, Yuvraj.
SSC last question. Some square
Sorry?
error. Some squared error question in
Okay.
qualifier for questions.
Some square. Okay, let me see which question. Question number.
Last questions.
Just 1 minute. Yeah, so Sushmita was calculating SSC and she found out SSC in the function of A as follows, right? This question. Okay.
Yes, sir.
Not sharing. Yes. So what is your doubt in this?
So can you save the like screen?
I'm sharing my screen, right?
Okay, sir. Good.
Yeah. What should be the base fit curve like?
So 0. If we'll put 0, then it will be 18 FA. Then if we'll put 9, then it will go in like in maximum number. Like it will go more than 0 if we'll put. Like we'll put 0, then it will go 18. If we'll put 19, then it will be more than 18. Then it will be the 0 answer.
How?
Sir, I have a thing to say here. So, this is a parabolic equation, right? And it is opening upward.
Yuvraj, can you please mute? Okay. Yes, sir.
So, this is a parabolic equation and it is opening upward. So we know that
Upward.
the minimum value of the SSC
be
we
at
will get at the vertex point,
vertex.
which is the x coordinate, right? I mean minus b by 2a.
Minus b by 2a.
So
right?
we need to find that minus b by 2a for this particular equation, and we need to feed that to this function, which is f of minus b by 2a. That would be the best fit value, na sir?
Yeah, so we have to find out the minimum value, right? SSC
Yeah.
base fit means for which we get minimum value.
Yeah. So for upward parabola, we know that at the vertex we are going to get the minimum value. So we need to find the minus b by 2a, then feed it to this function. So the value would be the answer, na sir?
Vertex, if we calculate, we will get 6, right?
9. So it's 3, sir, I guess.
I think
minus b by 2a, so it's minus of minus 6 by 2 into 1.
This is a function of A.
Now minus 3 will be b by minus b by
no,
8 is
it's
minus
3
3.
only.
Minus 3. When you put minus 3 in the function, it will be 9 answer. 6 is 18.
It's not minus 3, right? It's minus of minus 3 minus 6 by 2a. So 2 into 1. So it will be 3,
So
right?
3. Yeah, 3, 6 are 18. 18 minus 18 is 0. So 3 into 3 square is 9 answer.
See here. So if you what is the vertex vertex minus b by 2a, right? So minus b is minus 6 here, right? So if we put and yeah, 2a is a equals to 1, so that is 3, right? So if we put 3 here, what we will get? 9 minus 18 plus 18. So yeah, 9 is the answer, right? Plus 18 minus 18 will get cancelled.
Yeah.
Hello, b is minus 6 here. So minus will get plus, right? Naren, sorry, Sayan.
No, sir. We are getting plus 3, sir. Let's calculate the value. If we are
Yeah,
getting
so
minus
plus
b is
3.
equals to minus 6. I mean, b is equals to minus 6, right? So minus
So
b
it's
by 2a makes it minus 6 minus of minus 6 by 2a. So which is plus 3, na, sir?
Correct.
so minus 2a.
Yeah, correct, sir. Correct.
Sir,
3.
sir. The vertex formula is x equals to minus b by 2a, na,
Plus b
sir?
by 2a, right? Huh.
So now if we feed the b is minus 6, no, sir? So the minus we have in the formula and we are putting minus 6. This is making plus 6, no, sir?
Plus 6, yeah.
So
Then
it's like 3, no, sir? So
No,
we are getting
three
the
only,
answer
na?
9.
we calculated a as 3, right? Here, so
Yeah.
3.
Yeah.
Just
So
put the
it will
value
be
of a.
minus 6 into 3 will be minus only, right? So minus 18 plus 18 crossed out.
Yeah, exactly.
And
We are getting 9.
9 only.
Yeah.
Yeah.
Correct only. So it's 9 only the answer.
Yeah.
So this is I'm saying now.
Sir,
You said
Sir, the
minus 3,
confusion
something like
was
that.
like
Yeah.
something else. Sorry, sir.
Yeah.
Sir,
That's why I thought why minus 3.
Sir, I will just read what is given in that book regarding the reflexive. So one, they have given R1, R2, R3. R1 and R2, they said it is reflexive because it contained all the thing. R3, they've told R1, it's not reflexive relation because 3, 3 is not element of R2. In R2, that 3, 3 is not there. Since here R1 and R3 are reflexive relations, but R2 is not reflexive relation because 3, 3 is not element of R2. You understood, no, sir? 1, 2, 3, 4 was the set. So in other things, they again 1, 1, 2, 2, 3, 3, 4, 4. 1, 1, 2, 2, 3, 3, 4, 4, and 2, 3 also extra one element also. But in a one thing they have given only R1, I mean 1, 1, 2, 2, 4, 4 for 3. 3, 3 is not there. Since 3, 3 is not there, it is not a reflexive relation. That is what is given in the textbook. You understood, no, sir?
Yes.
For a relation to be called as a reflexive relation, there should be all the elements of the set A, which means it should contain reflexive that relation should
So
contain 1, 1, 2, 2,
R5 is
3,
also
3.
reflexive here, right?
Yes.
Yeah.
So there will
So
not be
R2 and
5.
R5.
Answer cannot be 5.
No, R5 is all. I'm saying about relation for R5.
No, that is what R5 correct, sir. Answer is 5. They have given is
R2.
5. R2 and R5.
Yeah,
Only
these
these
two should
two.
be there.
Yes. I have answered as 2, but the answer is 5. Answer is 5.
Transitive relation, right? Reflexive relation. Answer is 2 only, no? Possible answer 2. Reflexive relations 2.
Okay, that 5, what is that, sir? 1 second. That
5
question.
is for transitive relation.
Okay,
You
transitive
can see.
relation.
Yeah.
Answer is 5, sir.
Yeah, answer
Which
is
all
5.
5, sir?
So I think
Okay,
R6 is not a transitive, right? So R1, R2, R3, R4, R5 are all are transitive.
Are all transitive. Okay. I have
Because
put
if 1, 3 is there, then it is also transitive. Yeah.
R1 to R5, not sir.
R1 to R5, yeah.
Okay, sir.
So my answer, because even R6 I have taken as transitive, that's why it is wrong. Okay.
No. 1, 3 should be there. Yeah, that's what I'm saying.
Okay. I got it.
Yeah, so it's R2 and
clear.
R5. Sorry, yeah. R2 and R5 are reflexive relation, right?
Sir, when we can see our answer sheet, I can, because I
This
don't
is
remember
provided
what
on the portal, right?
No, but I don't know what I actually did on that day, kind of.
I don't think we are providing that.
And marks and all that, so we'll at least know
Yeah.
what.
Yeah, marks will give. Yeah. It had to come
Okay.
result. So yeah.
Okay, now I understood, sir. I understood about transitivity. Yeah, correct. Okay. Just like the reflexive reaction, wherein you should have all the elements. In transitivity also, it should all the elements should satisfy transitivity.
Transitivity, right?
Otherwise, it is not transitivity.
Right.
Yes.
Yeah.
Yes, Piyush, sir. Thank you very much. We will discuss it.
Yes.
Sir, are you gonna
I
end
can
the
leave,
session?
sir.
Or I have a doubt, sir.
Yeah. Wait. Yes, Naren.
I can leave.
Yes. We are just taking it out. Yeah. You can leave.
Thank you, sir.
Okay. Thank you. Yes, Sayan.
Sir, it's the practice assignment question number 3. I have tried, but sir, I don't know if my approach is wrong or right, sir.
So,
Can you
like
please
which
help me
week?
with that? 7, sir.
6, 7. Okay. Question number 3. Okay. Let me take this question. Question 3, right? Sequence is defined as that question, right?
Yes, sir. An is defined, and we gotta find the limit of the sequence Bn.
Bn value.
Yeah.
Okay. Just 1 minute. My screen is visible? This one?
Yes, sir. Yes, sir. Yes, sir.
Yeah. So an is given to us, and we have to find out the limit of sequence Bn, which is defined by this. Okay. So simply we need to calculate the limit of this particular sequence, that is limit n tends to infinity an.
An, yes,
and whatever the value you are getting, you can simply put instead of an here.
Okay.
And for here again also, you have to take the limit n tends to infinity 31 n square upon n cube plus 1, right?
Yeah.
Yeah. So if you if you take n cube common, what we get here?
So yes, sir. We are
0
getting.
only, right?
Yeah.
Yeah.
So
So
it
0
is
here.
0
So
by
this will be
something.
eliminating.
Yeah. That is 0. Yeah.
Not 0 by something. Here we get 31 upon n plus 1 by n square.
N square. So it's.
So that is, it is 0, right? So 31 by infinity, that is n, is 0, right?
Sir, I'm actually getting 0 by 1 plus 0. So, so it's 0. So basically it's 0.
Yeah.
Okay.
0, right?
Yeah.
So just find out the value of this particular limit and just find out 4913 into that value square and 289 into value. But separate, we have to calculate the limit for this
Limit
particular
of
function.
an, right, sir? We need to find
An only.
Yeah. Okay.
So it will be 1 only, right? If we divide by n, so 17n plus 16 upon 17n plus 17. So just divide by n. Yeah. So 17 plus 16 by n.
N.
Upon
Yeah.
17
17
plus
plus
17
17
by
by
n.
n. Yeah. So it's
Yeah. So
17 by
limit n tends
17.
to infinity. Yeah. So this is 0, this is 0. That is 1, right?
Yes,
Now
sir.
if you put 1 here, so that is 4913 into 1 plus 2893. So that is 0, right? So I guess 2 1 0 1 10 2 5 0 5 2 0 2 is the answer. Let me check. 5202. Yes, 5202 is the answer, right?
Okay, sir. Sir, I did the same approach. Exactly same approach, but I'm not getting the answer, sir. I don't know why. Maybe I have made some calculation mistake, but whenever I'm doing that, like my coefficients are different. So it is like 12n and 38n. So if we take the limit, I mean, if we want to find the limit of that an function, or sorry, not function, sequence. So so it should be, if let's say I have, not let's say I have actually, so it's 12n by 38n, and the other part would get cancelled. So it is like 12 by 38, right? I mean the limit for a.
This much expression you have, an. That's it.
Yeah.
No
So
plus minus.
yeah. So it is 12, right? So I need to put that n, that value in the bn sequence, and since the last n square part is eliminated, so that's fine. So I did that. I used the calculator. I didn't use. I mean, I didn't calculate it by myself because I know I might make some mistake. But still, my answer is not coming out right. I don't know why.
So what is the answer? Instead of an, it is 12n by 38n, right?
No, sir. The plus thing I just omitted since it's not needed because it's getting 0
Okay.
and something like that. So
212 by 38. Right?
yeah, so this is the value. Yeah.
Okay.
So I'm getting like 6,000 something. I don't know why. And the answer is 5928.
Okay.
I don't
So
know
it is 6
what is like, where am I making a mistake? I have no idea. Sir.
is 6 by 19 square plus 289 into 6 by 19, right?
No, sir, the function is different as well. It's not the same function.
Okay, function is also different.
Yeah,
Just
function is
try to
also different.
simplify.
Okay.
You missed. Yeah.
Okay.
I think you have done some calculation mistake. You can try.
I also think so. Okay, sir. I'll do that again. And if I can't, then I'll just post it on discussion forum,
Yes,
like
yes.
with my calculation and all that. And sir, question number 5, sir.
Same assignment.
Yeah.
Yeah, okay.
Sir, there's a in the factorial part I'm having issues. I don't know how to approach the factorial part actually. Yeah, that one, sir. The factorial part. I have no idea how to approach that factorial part. I mean,
So n factorial. Okay. So if you're in the sequence an, note that an equals to e. Find out the limit. So we are given a note that limit an equals to e, right?
yeah.
So if I put limit n tends to infinity, n factorial, this one is n, right?
Wait a second.
Okay. So limit an tends to e. So if I replace n by any number here, hello?
Yes, sir. You're audible, sir.
Yeah, replace n by any function and say 2n plus 1, I will just still limit e only, right?
Yes, sir. That is true.
Yeah. So ln of e plus ln of here also same thing, ln of e. So ln of e plus ln of e, that is twice ln of e, right? So ln of e, this ln is natural log here. So ln of e to the base is 1.
Yeah, 1.
So
Yeah.
answer should be 2. Answer should be 2, right?
Oh, okay. Got it, sir. Got it. So
Ln of e plus ln of e, yeah.
okay. So the factorial part is just to confuse us. So the basic thing is
Yes.
in the an part. Okay, sir. Got it, sir.
Already given that, right? Note that limit an equals to e.
Yeah. So I couldn't I didn't find any way to put that. So that's why I was having an issue. Okay. Thank you, sir. Thank you.
Okay. Thank you.
Thank you, sir.
Okay. Thank you, everyone.
Thank you, sir.
Thank you. Good night.
Good night.
Thank you. Good night.
Good night.